Hello friends, we are going to write an algorithm to convert a binary number to a decimal number. For example, if I am giving a binary number 100, it should be converted into an equal decimal number 4. For this, we will write an algorithm. Step 1 is the logical start of the algorithm. Step 2, I ask the user to enter a number. I am using a print statement. Print enter the number. Here the number means it's a binary number. Step 3, input b. I am obtaining a binary number in the variable b. Step 4, I am initializing two variables, set d equal to 0, p equal to 0. Step 5, I am using a for loop for I in length of b minus 1 to 0. So what it will do? It will start from length of b minus 1, total length of b minus 1. For example, my binary number is 100, which is stored in b, the length is 3. So it will start from length of b minus 1, 2. From 2 up to 0, the loop will go. So here I am writing step C equal to b of I. Okay, the b of I initially I is having value 2, b of 2 will get stored in C. Next step, d equal to the existing value of d plus c multiplied with 2 to the power p. Next step, I am incrementing p by 1, p equal to p plus 1. So this is the end of the for loop, end for, the end of the for loop. Next step, I am printing the result d. Step 6, print d. That means the binary number b is converted into a decimal number with the help of this logic. Step 7, stop. This is the logical end of the algorithm. Start, I ask the user enter the number, input b. The number means binary number that is stored in the variable b. I am initializing two variables, d equal to 0, p equal to 0 for I in length of b. That means I will start from length of b, then it will go to 0. It will every time the I value will be minus until I is become 0. So here c equal to b of I. b of 2 will get stored in c. Then d equal to d plus c multiplied with 2 to the power p. Initial value of p equal to 0. Then I am incrementing p by 1. The loop will continue until I is become 0. So we will trace how this logic works by taking a sample example. So this is the end of the for loop. Then the print D, printing the decimal number of the given binary number, decimal equivalent of this given binary number. Step 7, start. Now we will take a sample input and check how this algorithm works. Start, print, enter the number, input B. My input is 100. It's a binary number. 100 is the binary number. So we can say this is the 0th question and first question and second question. 0th question I am having a value 1. First question I am having a value 0. Second question I am having a value 0. So set D equal to 0, P equal to 0. So I am initializing D equal to 0, P equal to 0. For I in length of B minus 1. So I value I equal to length of B minus 1. So what is the length of B? Length of B is totally 3 digits, which is equal to 3. Minus 1, which is equal to 2. I equal to 2. C equal to B of I. C equal to B of 2. So what is the value in the second question of this B? Which is 2. B of 2. B is an array. So B of 2 is stored in C. So I am having a value C equal to 0. The second question, in the second index question, I am having a value 0. D equal to existing value of D. D equal to existing value of, what is the existing value of D? Which is 0. Because D is initialized as a 0. 0 plus C. What is the value of C? C is 0. 0 into, what is the value of P? P is 0. 2 power C into 2 power P. So 2 to the power 0. So here 0 plus 0 into 2 to the power 0, 0 into 1 equal to, okay, 0. So entire term is 0. 0 plus 0 into 2 power 0 is 1, which is equal to 0 plus 0, which is equal to 0. So now the D value is 0. P equal to P plus 1. P equal to 0 plus 1, which is equal to 1. P is become 1 now. So our first iteration is over. Second iteration, again I is become existing value minus 1. So it will move from the length of B minus 1 to 0. So existing value of I, what is the existing value of I is 2. So 2 minus 1, now I equal to 1. I equal to 1. C equal to B of I. C equal to B of 1. So what is the value in the next question? 1 of B, which is 0, which is equal to 0. D equal to existing value of D is 0. 0 plus, what is the value of C? C equal to 0. 0, okay, C into 2 power P. What is the value of P equal to 1? 2 power 1. So existing value of D is 0 and the value of C is 0. So 0 plus 0 into 2 power 1. That means D equal to D plus C into 2 power P. So D is 0 plus C is 0 multiplied with 2 to the power P is 1, which is equal to 0 plus 0 into 2 power 1 is 2. So 0 into 2 equal to 0, which is equal to 0 now. So D is 0 now. P equal to P plus 1. P equal to existing value of P is 1. 1 plus 1, which is equal to 2. The second iteration is over. So now I am writing the next iteration here. Now again I value will get subtracted by 1. I equal to 0. C equal to B of I. C equal to B of 0. C equal to B of 0. That means, what is the value of B of 0? 0th question I am having 1. So this is equal to 1. C equal to 1. D equal to existing value of D. What is the existing value of D? It is 0. 0 plus, what is the existing value of C? C is 1. So now it is 1. 1. What is the value of P? Is 2 multiplied with 2 power 2. So here I am getting 0 plus 1 multiplied with 4, which is equal to 0 plus 4, which is equal to 4. So this is my output. What is my input? So 100. 100 is my input. My output is 4. So this is the decimal equivalent of the binary number 100 is 4. This algorithm is working perfectly. This algorithm will work to convert any binary number into its equivalent decimal number. That's it. Thanks for watching this video. Please subscribe to my channel, share, comment and press the bell button. Thank you.